Okay, let's continue with this example. Now that we've got the tree diagram fully completed, let's look at the different parts, A, B, C, and D. So part A is to calculate the probability of 2 red. So this is going to look like the probability of red and red. So if we look down here on our tree diagram, we look across the bottom at the outcomes of drawing 2 marbles. We've got down here the probability of blue and blue, the probability of blue and red, the probability of red and blue, and here the probability of red and red. So this is the one that we're interested in for part A. So the probability of red and red is going to be 9 over 121. So I've created space on the next page to fully calculate this out. So calculate the probability of 2 red. So we've got the probability of red intersect red is 9 out of 121. You put that into your calculator, you're going to get 0.0744 rounded to 4 decimal places. Convert that to a percentage by moving the decimal place over 2, and that's going to be 7.44%. Okay, next, let's calculate the probability of 1 red and 1 blue. So when we look at the probability of 1 red or 1 blue, the order of blue and red does not matter. So what we could get is we could have the probability of maybe getting blue first and the probability of getting red first. Either way, we're getting 1 red and 1 blue. And because we don't care about the order, it's going to be the probability of blue and then red, or the probability of red and then blue. And we want the probability of all of that. So what we've got is the probability of blue intersect red plus the probability of red intersect blue. So let's look and see where we have these in our tree diagram. Okay, so we're looking for the probability of blue intersect red. So here's 1, and then the probability of red intersect blue. So for both of these, it was 24 out of 121, 24 over 121. So that's for part B. So let's go down. So the probability of B intersect red was 24 out of 121, and we're going to add 24 out of 121, which gives us 48 out of 121. Put that into your calculator and round that to 4 decimal places. You're going to get 0.3967. Move the decimal place over 2 to convert that into a percent, and you get 39.67%. So the probability of getting 1 red and 1 blue is almost 40%. Okay, next, let's calculate the probability of drawing a red first, followed by a blue. So we're specifically looking for the probability of red first and blue second. So where do we have that in our tree diagram? So the probability of red first and blue second is here. And so that's going to be our answer for part C, 24 over 121. So 24 over 121 rounded to 4 decimal places is 0.1983. And in percent, it comes out to 19.83%. Okay. So this last part, part D, is a conditional probability. Now, even though we're dealing with experiments where the events are independent, and we wouldn't normally use conditional probability for events that are independent, in this particular example, we're being forced to consider a conditional probability. And so we're being forced to consider a conditional probability by saying, calculate the probability of drawing a red given the first ball was blue. So what we're looking at here is what's the probability of drawing red given that the first ball was blue. So this is, an example of conditional probability. And what this means is not only do we have to look at the blue marble being chosen first, but it's also going under the assumption that the blue ball drawing that first has already happened. It's a foregone conclusion. It's already happened. So let's look at the consequences of that in our tree diagram. And let me use a different color, maybe so that will stand out a little bit more. Okay, so we are looking for the probability of red given that blue occurred first. So here's our first draw. And if blue occurs first, that means we're going to be here in this position. So because of this wording, blue has already occurred. So we don't need to incorporate the probability of blue into our calculation. Instead, because we know blue has occurred, we're only interested in this branch going to red. And so this branch going to red is the probability of red given that blue has occurred first. So this becomes your new starting point with conditional probability. And so the probability of red given that blue has occurred first is going to be 3 out of 11, the same as this. So we can come back to our problem. So the probability of red given that blue has occurred first is going to be 3 out of 11, rounded to 4 decimal places. That's 0.2727, which is 27.27%.